An object from another star system has now arrived in the solar system. This is not an ordinary interstellar visitor, nor is it a nearby asteroid or a comet fragment from the outskirts of the Oort cloud. Comet 3. I-Atlas turned out to be exactly such an object. The most interesting thing is that we managed to study it in quite some detail before it began to disappear into the darkness of space. So what did we actually see? The comet has already passed its closest approach to Earth. Does it pose a threat? In a short period of time, several telescopes captured new images that unexpectedly showed the object remains the same, but looks different with each observation. Visual, infrared, and ultraviolet data show that the comet literally changes its appearance in different ranges of radiation. Its green glow easily brings to mind UFOs and little green men, as if something extraterrestrial is hidden inside. However, the real explanation is much more interesting. In just 6 months of observations, by the end of 2025, 3i Atlas has already significantly changed our understanding of what interstellar comets look like and how they behave, as well as how chemistry works beyond the solar system. At the point of closest approach, the distance between the comet and Earth was about 270 million kilometers, almost twice the current distance from Earth to the Sun. That may seem enormous, but for modern telescopes, such a distance is quite accessible. Some of the most impressive images were captured by the Gemini North telescope. If you compare the before and after images taken by the same instrument, the differences become striking. In July, after its discovery, the comet had a slightly reddish tint. Its origin is most likely related to the so-called tholins, complex organic compounds formed by billions of years of exposure to cosmic radiation and ultraviolet light on organic matter. It is the tholins that give Pluto its characteristic reddish color. There is nothing unusual about this. However, then something unexpected happened. The latest images showed that after emerging from behind the Sun at the end of November, the comet became noticeably green, and a stable green halo formed around it. Usually, this color indicates the presence of diatomic carbon, C2. These molecules are released when heated, get excited by solar radiation, and start to glow in the green part of the spectrum. Almost all comets turn green over time, but an important question arises. Why did 3i Atlas do this much later than the comets of the solar system? The most likely explanation is an unusually thick and strong surface crust, formed over billions of years under the influence of intense cosmic radiation in interstellar space. Such a shell prevents heat from penetrating into the core for a long time. The physics of the processes is the same, but the object's history is completely different. And that's not all. Data from the X-ray multi-mirror Newton X-ray telescope was published, which observed Newton's comet continuously for 20 hours, and as a result, faint X-ray radiation was detected. It occurs when the gas emitted by the comet interacts with the solar wind, a stream of charged particles from the Sun, resulting in X-ray fluorescence. Why is this important? X-ray observations are especially sensitive to gases like nitrogen and molecular hydrogen, which are almost invisible to optical telescopes. Including Hubble, we were actually able to see the hidden components of the comet that would have otherwise gone unnoticed. How many more such objects are we not seeing in the coming months? This data will help determine the composition of 3i Atlas more accurately, and Hubble has also contributed. The latest images show that the comet has become brighter and visually larger. Special attention should be given to the study by 3 European scientists, which showed that the behavior of 3i Atlas indicates cryovolcanic processes similar to those observed in trans-Neptunian objects. Inside the nucleus, there is a significant amount of dry ice, solid carbon dioxide, which quickly turns into a gaseous state when heated. This triggers the circulation of oxidizing fluids that interact with grains of nickel and iron. A chain of chemical reactions begins, a kind of internal corrosion, which leads to the release of jets, gas, and dust, altering the orbit and causing non-gravitational acceleration. Similar processes are known in the solar system, but here they occur in an object that formed in another star system. All this points to an extremely high carbon content. The comet releases more methanol and hydrogen cyanide than any known comet in the solar system. Methanol, in turn, is an important component of the precellular chemistry of early Earth. The JUICE spacecraft, while near Jupiter's icy moons, detected a bright coma, a plasma tail, and a weaker dust tail. The dust tail curves because its dynamics are different, and it always points away from the sun. The Europa Clipper spacecraft, using ultraviolet observations, was able to distinguish the coma's core and the dust tail, and also detected oxygen and hydrogen, even with a dense gas envelope. According to the latest estimates, the mass of the comet is about 44 meters, which is extremely small. Instead of the originally assumed diameter of 5 kilometers, the nucleus turned out to be just over 700 meters in size. It was also found that jet activity at high latitudes is weak, and the rotation period of the nucleus is about 15.5 hours. This is the first time that an interstellar comet has been studied in detail without direct observation of its solid nucleus. The movement of the object noticeably accelerated due to active gas emission, and the effect was intensified by its low mass and low moment of inertia. Finally, it's worth mentioning the signals that sparked a wave of rumors. We're not talking about messages or attempts at communication. Radio spectral observations conducted by the MEERKAT array and other radio telescopes detected hydroxyl group lines, standard indicators of water in comets. These signals have been known for decades. The only unique thing is that they were detected from an interstellar object. In the end, it all started with an almost accidental discovery. The ATLAS project detected an object that was initially thought to be a regular near-Earth body, but its hyperbolic orbit quickly revealed to us the third known interstellar object. This clearly demonstrates the effectiveness of systems that constantly scan the sky and provide protection for Earth. Right now, 3I ATLAS is leaving the solar system, passing Jupiter's orbit, then the outer planets, and will eventually leave the heliosphere, dissolving into interstellar space. But the information it left behind will continue to change our understanding of the universe for a long time. How many such visitors have already passed by us unnoticed, and how many more are yet to come?